So we're asked to find the derivative of the function. Notice that they didn't say, like what we've seen in previous problems, they didn't say the derivative at x equals 2 or something like that. We just want to know what f prime is with respect to x. What is the full function, or the full equation that represents the derivative. So in order to do that, we have to plug in the limit. Let's see. Let's do this one. The limit as x approaches h for f of x plus h minus f of x over h. Okay. Because this time there's no 1 point, there's no a. It's just getting infinitely close to every point on the function. So we can plug in. We can plug in x plus h in for x into the function notation. Then it's minus 2 here. So x plus h minus 2, all being square rooted. So that's this part. Now we subtract that by f of x. It's all being divided by h. So it looks like we get another tricky algebra situation here. Let me think about what we can do. Well, when I'm in doubt, I always multiply by the conjugate. It could be messy, but it could help. So this is x plus h minus 2 plus the square root of x minus 2. So I've got the same thing, just with a different sign in the center. That might make the denominator start looking complicated, but oh, geez, I have my limit notation wrong. I was going to say, because as long as we don't have a divide by 0 error, we're all set. This is bad. I was mixing both the limit definitions of the derivative. This should be as h approaches 0, right? So what we do to the top, we got to do to the bottom. And we don't really care how messy the bottom gets as long as we get out of this divide by 0 problem. So on the top, when you have this square root times this square root, the square root symbol is gone, and now we just have x plus h minus 2, because it's the same thing multiplied to itself. Over here, you're going to have, well, you're going to get something complicated, but it's going to cancel out because of the conjugate. I don't know if I should take the time to write it out. That might help. But this times this is going to give us the square root of x plus h minus 2 times square root of x minus 2. But we're going to get the opposite here. Square root of x plus h minus 2 times square root of x minus 2. Those middle terms are going to cancel out. That's the whole point of multiplying by a conjugate. And what we're going to be left with is the last pairing that we haven't done. The square root of x minus 2 times the square root of x minus 2 gives us x minus 2. So that's what the numerator looks like. The denominator is looking worse. But we don't care as long as we stop that divide by 0 problem somehow. So look in the numerator. The x minus x, that's going to cancel. This is a minus a negative 2, so that's negative 2 plus 2, so that's gone. You're just left with h in the numerator. And so that means h and h cross cancel, so you're left with just 1 over the square root of x plus h minus 2 plus square root of x minus 2. So now we don't have a divide by 0 problem. As h approaches 0, this thing becomes the square root of x minus 2 plus the square root of x minus 2. Or it's the same thing added to itself, so put more simply, that's 2 square roots of x minus 2.